Hello and welcome back to Calculus 1, section 5.4 on working with integrals. Funny title, I know, but we're just going to work on few formulas. One of those formulas is going to be the average value formula, and then when you flip it around, you get the mean value theorem for the integral version of the mean value theorem. So that is the same formula. The one is just algebraic manipulation, but you can keep it as two formulas. And then the other two formulas will be exploiting the even and odd functions and the symmetry in the interval. So let's start with the even, odd, and the symmetry. So first, we have to travel back in time, as we usually do in calculus, to take a look at some prerequisites that you might have forgotten. And that would be, what is the meaning of function being even or being odd? You know that numbers are even if they're divisible by 2, and they're odd if they're not divisible by 2. So that's that for numbers. Now, what does it mean for functions? Well, odd functions obey the rule that f of negative x is the same as negative f of x. So if this rule holds, you have odd function. And then even function, so even functions obey f of negative x is the same as f of x. Now, generally, the two examples that are go-to examples are sine and cosine. But you memorize those from trig. I like to use a quadratic function that has no linear term, and then a cubic function in its form with the linear term but without quadratic term and without the constant. So if I go and say that f of x is equal to x cubed minus 5x, this will be odd function. Because if you compute negative x, you will get negative x cubed plus 5. And if you compute negative f of x, you will have the same answer. You see that? Oops, I forgot these x's on there. So you get the same, which means odd. There we go. Now, if you have a function that says, let's say, let's go with g now. So g of x is equal to 3x squared plus 9. And you compute your f of negative x, it's going to be 3 times negative x squared plus 9, which is still 3x squared plus 9. And that's the same. So it's even. Yeah, too big. That's what I said. Please pay attention. It's clearly g of negative x. So this is just prerequisite from your pre-Calculus 1, chapter 1, lecture like 3 or 4, whatever. So it's the beginning of your functions in life. Now, what are the calculus formulas that utilize these? If I have integral on a symmetric interval negative a to a of f of x dx, and this f of x is odd, the answer is always 0. This is a quality of life formula. In certain courses, it will cut out a page of calculations. Now, that's clearly 400 level, 500 level, 600 level math. We're talking graduate school and so on. To calculate coefficients of the Fourier series, 480, it's going to use this. It's a full page calculation, but then you know, oh, it's a symmetric interval, it's an odd function, it's 0. Boom, page of calculations skipped, right? So again, is this going to be useful to you? No. Until you get there, right? And then it's like, oh, wow, it cuts out 20 minutes. Nice. We have another one. The integral on the symmetric interval again. So this is like -2 to 2, or -10 to +10, right? That's -a to a. On a symmetric interval, f of x dx, where f of x is even, is going to be 2 times integral 0 to a of f of x dx. Now this one could be useful to you now. So yeah, that's that. That's the 2 formulas, and now formula number 3. Average value. So average value of function is 1 over b minus a integral a to b f of x dx. Yep, that's that. Note that I'm just listing these formulas. You should be able to compute, right? The computation is integration from 4.9, calculating definite integral for 5.2. We're not learning anything new in terms of calculating these things. You're learning new formulas that are applying in certain situations. And that's the end of it. So for the average value, let me go pick up a problem from the textbook so we can find. Is the stream working? Yeah, because my dashboard over here is not happy. Whatever. Working with integral. Let's go substitution rule and go to homework. I'll find why is 5.3? There we go. So average value for cosine 2x negative, so let's go 24. Average value for cosine 2x on negative pi over 4 to positive pi over 4. All right, so that's going to be f average is equal to 1 divided by pi over 4 minus negative pi over 4, that's a minus b, b minus a, integral negative pi over 4 to positive pi over 4 of cosine 2x dx. Ooh. What can you tell me? What kind of function? And what do we have here? We'll go with that one later. What do we have here? What's circled? Well, what kind of function is this? Even or odd? Cosine is? Cosine is even, yeah. Cosine is even, yes. All right, good. So cosine is even. So the whole thing is 1 over pi over 2 integral 2 from 0 to pi over 4, because we are going to of cosine 2x dx, right? So now we have 4 over pi, and then integral of cosine is sine 2x over 2 computed from 0 to pi over 4. This is 2 over pi, and then sine of pi over 2, which is 1, minus sine of 0, which is 0. So the whole thing is 2 over pi. And we didn't just do the average value, we actually also used, this is awesome, we used one of the previous formulas to calculate that. So I have a function cosine 2x on the symmetric integral minus pi over 4 to pi over 4. Yes? Here?
Yeah.
I changed the limit to from negative pi over 4 because I used the blue formula here.
Okay.
That's negative a to positive a. That's negative pi over 4 to pi over 4 is 0 to pi over 4 with a 2 pulled out. That's the new formula. You don't know it yet, so that's why it looks weird. But as soon as you get there, it will be clear. And I think we're done, right? Oh, the mean value theorem. The mean value theorem is the same formula, and you just equal it to f of c, and you can find that c at which, right, you have the average value. So that's well, let's add that. So MVT for integrals. So f of c is f bar, which is 1 over b minus a, integral a to b f of x dx. So maybe we can, let's go hunt for the problem and call it a day. So mean value theorem for integrals. Let's just do e to the x 0 and 2, quick and so find c for f of x equals e to the x on 0 to 2. I forgot what is the problem number for that. That's problem 36. Well, we have our f of c to be equal to f bar. Well, f of c is e to the c, and f bar is 1 over 2 minus 0 integral 0 to 2 of e to the x dx. So just compute this. So e to the c is equal to 1/2. Integral of e to the x is e to the x, computed from 0 to 2. So e to the c is equal to 1/2, and now you have e squared minus 1. And all you need to do is to solve for c. So you will ln both sides at this point in life. When you ln both sides, you get c is equal to, and now you have ln of 1/2 plus ln of e squared minus 1. That's actually a number that you can go in the calculator and figure out, you know, value for it if you're interested. Yeah, that's that. I hope you're not disappointed. But we got the value for C. See you all tomorrow. Use sub. Make sure you do your class preps for tomorrow. Make sure you read the section 15,000 times. I mean, if you're going to Calc 2, obviously. If you are not going to Calc 2, then you just need to survive the 2 problems on the final from that section. See you tomorrow.